Today we're going to investigate the intersection of two planes. And as we move along in each day, it becomes harder and harder to demonstrate these in real life, but we'll give it a shot. But of course, I'm going to demonstrate on GeoGebra as well. So we're going to investigate the intersection of two planes, which I'm going to represent with one piece of paper and a second piece of paper as the two planes. So the first possibility is that the planes are parallel and distinct, which would look something like this. You can imagine the two planes being above each other and they're parallel and never touch. Okay. And no matter how, if you twisted it and they were different parallel ones, they would still never touch. So that's one possibility, parallel and distinct, and they're never touching. So you might be asking yourself, how are we going to demonstrate whether two planes are parallel? So I'm going to try and show that with a plane that I have resting on the desk and a second one that's hovering above it that is going to be parallel. First, let's talk about the plane that's on the desk. The defining characteristics of planes are their normals. So I'm going to represent the normal with this black golf tee. And of course, the normal is perpendicular to the plane. So you see it perpendicular straight out of that. And no matter where that normal lies, it's perpendicular to the plane. And even if I rotated the plane, you'll see that the normal stays with it. Okay, stays perpendicular to it. So there is our first plane that's on the desk and the normal that is perpendicular to it. Now let's investigate the plane that's above it that's parallel. Well, it also has a defining normal that describes the one defining characteristic of this plane. So I'm going to represent it with a green golf tee. And if you notice right now, you should notice that the green golf tee and the black golf tee appear to be in the same direction. And that's because their planes are parallel. And if I kind of remove this plane and look only at the golf tee, you'll see that it is in the same direction as the normal. And so if you only compare the normals, you'll be able to decide how the planes are. If the normals are parallel, then the planes themselves must be parallel. And I'll demonstrate it if we had a case where the normal was not parallel. So let's see, off like this. If I was to draw the plane that's represented by that normal, you can see it's not parallel. Okay, so the way you decide whether planes are parallel is you just look at the normals. And if the normals are scalar multiples of each other, then the planes that represent them, that are represented by those normals, must be parallel. The second possibility is that they are parallel but non-distinct, which means they are the same line. So here, or the same plane. So here they are, parallel and distinct, but if they were parallel and non-distinct, they would actually be the same line. And remember, these pieces of paper can go on forever. So even though it seems like only part of them are touching, they're all touching at all times. In that case, the intersection would be the same, and there would be infinite intersections. And then the third one is when they're non-parallel and distinct. So in that case, here they are parallel, here they are the same, parallel and distinct. So if I twist it and intersect it that way, this one would come down and intersect now at a line. It's very difficult for you to see that here, but the GeoGebra does a good representation, or you can imagine it like this, intersecting at a line. Okay, so they're going to intersect not at a point, but at a line, as one slicing through the other one. I'll turn over to Mr. Lee, who will demonstrate it on GeoGebra as well.
Thanks, Mr. Lee, for that awesome demonstration. We'll try and also demonstrate them here on GeoGebra, represent the three possibilities that can happen when you are investigating the intersection of two planes. So the first one that I demonstrated there was if we had one plane here, and then we had another one that was parallel to it, but distinct. And you can see then that the two planes are above each other, and no matter how you rotate it around, they are not going to touch. And so the intersection of these two planes would be none. And that would be our first possibility that you'll see in our notes. No intersection because the planes are parallel and distinct. The second case is where we have the plane here. Here's example 1 and equation 2 to represent the second one. And hopefully you saw that it mapped right on top of it because it turns out that these two are the exact same plane. So not only are they parallel, but they are the same plane. and therefore there are infinite intersections. And if you look closely at the equations, you'll see why they are the same plane. That the second one is merely a scalar multiple of the first. If you take all the coefficients and multiply it by 2, you will get the second one. So it's not real surprise when you stop and look at the equations that these are the same plane, and therefore there are infinite intersections. And that would be the second possibility. Infinite intersections because the planes are the same. And finally, the third one that is really hard to demonstrate with pieces of paper, but you can visualize them much better with these, is when we have two non-parallel planes. And so we have one plane like this and a second one coming down and intersecting at a line. And you can really demonstrate that line right there. And so then as I move it around, you can really see one plane slicing into the other. It's hard to demonstrate with pieces of paper. Okay, so you can have that, and you'll notice this one is not, they're not perpendicular to each other, they just happen to slice down in there. But if you look at my notes, I have the third is an intersection of line. The drawing that I drew kind of suggests that these two are perpendicular, but they don't have to be perpendicular. You can see them slicing down sort of like an X, but the result is that line. And of course, this pink plane and the blue plane will go on forever, so will that line, that intersection. This, I believe, is one of the examples that you'll see in your question, and so you'll actually see this note. I know it's hard to see the whole thing there, but you'll find out that this is your answer when you do all the math coming up. I have a second example here of two planes that intersect, and they don't have to intersect perfectly, but you can see through this demonstration, right, they're still slicing through, and your result is still a line right down on the bottom there. Bring it up here. Okay, so there is examples of, and I think this is maybe one from your homework as well. You'll see the three possibilities then, that the lines are parallel and distinct. So the conclusion is there is no intersection, or they are the parallel and the same, so non-distinct, they're the same, and therefore there are infinite intersections, or they are non-parallel and intersect at a line. Good luck.